Okay, so yesterday and the day before and last year, you solved one-step equations, right? Okay, so this just says two-step. All right, now, so yesterday, you don't have to write this down. I just want you to get this in your head, okay? So if I saw x plus 5 equals 17, how would I have solved that? I would have subtracted the 5 because I'm doing the opposite, right? And that would have given me x would be equal to what? With 17 minus 5? 12. Okay? So the only difference here is that we have two steps. All right? I'm adding one more thing in. Okay? So it would just be, I'm going to multiply 3x plus 5 to get 17 instead of just x plus 5 equals 17. All right, we still do the same, except our first step is right here in terms of we always start with a number that's by itself. So which number is not with the variable? 5. Okay, 5 is not attached to the variable. So the number that's by itself is the number we start with. So it's adding 5. Well, what's the opposite of adding 5? Subtracting 5. So 17 minus 5 is 12. So instead of that just being my answer, I bring this one down. So I have 3g is equal to 12. Well, we know how to solve that. How do we solve that? Well, it is multiplying. What's the opposite of multiplying? Dividing. Divide by 3. Divide by 3. 4. So you see how we just had to do something twice and then we got our answer, but do we solve any differently? No, we're still applying the same rules. It's just you have to do it twice. Now, is there a way to check our answer? If this makes me nervous, is there a way for me to go back and check? Okay, I solved for g, right? So in my equation up here, I could do 3. Well, 3g means 3 times g. I said it was 4. So 3 times 4 plus 5. So according to order of operations, or PEMDAS, what do I have to do first? I have to do my multiplying. What's 3 times 4? 12 plus 5 equals, so I got 17. Did I get 17 over here? So does that tell me I did it correctly? Yes. Okay. Yeah, you solve that one first, and then you solve for the variable last. Okay. So this next one, which one is by itself? Which one's not with the variable? 5. So it's subtracting 5, so I would add 5. Okay, look again. I have negative 19 plus 5. It's negative 14. Remember, when they're different signs, I subtract and keep the sign of the larger number. Okay, so then I bring my variable down. So 7k is equal to negative 14. It's multiplying by 7. Okay, so I divide by 7. A positive divided by a negative is a negative. Not so bad. Okay, so draw my line. Now, this is the same thing except it's just flipped, right?
Yeah.
So which number is not with the variable? 11. So it's subtracting 11, so I would add 11. Well, 13 plus 11 is 24. Bring my variable down. What would I do to solve? Divide by 4. Divide by 4. So 24 divided by 4 is 6. Remember, if I do this and it seems like I did something wrong, what could I do to check? Plug it back in for x. Okay. Now, here is where there were some questions, I guess, or a little bit of confusion. Now, this is problem number 4, right? So cover this up and look at it. What number is not with the variable? 15. How would I get rid of the 15? Subtract. Why do I subtract it?
Because
it's a positive, all right? Is it adding 15? Is it subtracting 15? Well, it's just 15. 15 is a positive number, so to do the opposite, it would be negative. Okay, when I have two negative numbers, what do I do with them? No, that's multiplying and dividing. But I took it away. I add them. So 9 plus 15 is? It is a negative. Remember, that's like saying I owed my buddy $9, but then they paid for something else. Now I owe them another 15. So I wanted to figure out how much I owed them all together. Okay. All right. I bring this down. So I have negative 2b equals negative 24. 12. All right. What did I do to get 12, Trey? Divide by negative 2. Divide by negative 2. So now a negative divided by negative is a positive. Good. I think y'all are doing pretty good so far. Y'all feel like it? Yeah? Because it's the opposite, just like we did on all these other ones. In order for me to be able to bring it over to this other side, like I did here, I have to do the opposite of what it is. So if it was a positive, the opposite is negative. Remember, subtracting and negative, it's the same thing, just like a positive and adding. They're the same. Essentially, it's the same thing. Okay? All right. Here. So see how if I cover that up, that is a negative. I didn't have that here. All right. So a negative tells me I would have to do what to it? I'd have to add it. All right. Well, 40 plus 5. 45. Bring my variable down. So 3w equals 45. It's multiplying, so I divide. Dividing by 3 would get me 15. Okay, try number 6 on your own. And give me a thumbs up when you're done. Robert, make sure you're working, bud. Thumbs up. Give me thumbs up when you're done. Okay. Those look harder on the back, but they're not. They're not. So all I asked for y'all was to try, right? Okay. Okay, I'm seeing almost everybody. All right. So what would I have to do first? I'd have to subtract 2. It's adding 2. 2 is not with the variable, so the opposite would be to subtract. Okay, so negative 48 minus 2. Negative 50. Good. Bring down my variable. Okay, then what? Divide by 5. Negative 10. Good, Hattie. So B is negative 10. If you didn't, do we know why? Okay. Was it a simple error? Okay. Simple errors are easy to fix, right? Okay. All right. Let's flip it. Now, the back, it looks worse than it is. It's really not bad. People actually liked these better than the ones on the front. All right. So, yeah, it looks a little bit more complicated, right? But it's not. I still am applying the same rule. I start with a number that is not with the variable. So which number is not with the variable? 7. What do I do to get it to that other side? Subtract. Okay. So subtract 7. So what is it? 10 minus 7. So I have a larger, so it's just a positive. Okay. Then I bring this down. What does that mean? So that's z divided by 2. No. Multiply. Good, Xavier. What do I multiply? 3 times 2. So z is equal to 6. Was that as hard as it looked? No? Okay. So what about here? What number do I start with? 6. What do I do with 6? I subtract it. Yes, Trey. I would do what? I would add them. Why am I adding those together? They're both negatives, right? So negative 4 minus 6 is what? Negative 10. Good. Guys, y'all are doing good. I multiply because that's n divided by 5. So I would multiply. What'd you say, Hattie? Negative 50.
Can we try 9?
Let me do 9 with you first, and then I'll let you try 10. Okay? Because it's a tiny bit different. All right? Now, which number does not have a variable, doesn't have a friend? 7. Okay, so it's dividing by 7. Do y'all agree? That's z plus 5 divided by 7. So to get rid of that, I'd multiply. 7 times negative 3. Negative 21. Now, I bring this part down. So I have z plus 5. I would subtract. So minus 5, minus 5. But I really do what? Add it, which gives me negative 26. Now, somebody just looked at that and said that doesn't look right. What could I do to check and see if it was right? Plug it in. So if I had negative 26 plus 5 divided by 7, what is negative 26 plus 5? Negative 21. Negative 21 divided by 7. What times 7 would give me negative 21? Negative 3. So that's my answer. Is that what it was right here? So I did it right. Okay, so I'll let you try 10 by yourself. Give me a thumbs up when you're done.
So what about if the negative's smaller than the positive? So it'd be a positive.
Like, are you adding or subtracting? Or multiplying or dividing? Multiplying, it doesn't matter. If there's a negative and a positive, it's negative. You multiply normal and the sign is a negative. Still waiting on a couple people. Okay. What's my first step?
You have to multiply negative 3 and 12.
Multiply negative 3 and 12 and get what? Okay, then what? Subtract 9. Remember, there's no symbol in front of it, which tells us it's a positive. What does that give me? Negative 45. Good. Do you know what you did, Will?
I did the same thing y'all did.
So where did we go wrong?
Oh.
Was it where you got negative 36 minus 9?
I added
Okay. All right, so this next one is just a word problem, but it still gives you a two-step equation. A card game has 50 cards. After dealing 7 cards to each player, Daniela has 15 cards left over. Solve the equation to determine the number of players. Okay, so So remember, this P is representing how many people were there because each person got 7 cards. All right, there's 50 cards in their deck. So we go like this. What would I do first? Minus 50, minus 50. What happens when I take away more than I have? Negative. So, but can I subtract 50 minus 15 like normal? Yes, what is 50 minus 15?
It'd be negative.
35. All right. Then what do I do with that 7?
You bring it down.
Divide it. A negative divided by a negative is a, so it's positive 5. Good. You feel okay? Okay. So here's the 2 that you did at the beginning of class. All right, remember, this is the 4th time now that you've seen these problems. Change over originals. That means the change from the first number to the second number. Well, how did I get from 100 to 182? So I added 82. So my change goes on top. What was my original number? 100. Okay, so then I do equals percent over 100. Remember, when I have this fraction equal to a fraction set up, I do what to solve? Cross multiply and divide. So 8,200 divided by, what do you mean? Because it's the change. To get from 100 to 182, I'd only have to add 82. Okay, so I have my zeros. I can do the zero trick, cross them out. How many times would 1 go into 82? 82. So I have an 82% change. Pretty easy, right? Okay.
I didn't think I was doing it right.
Because it was too easy. Sometimes it can be easy, guys. Yes, it is. Well, these look super hard, right? But were they?
No.
Okay.
That's tricky. Plays with you. With your mind.
All right. How do I get from 20 to 80? 60. What's my original number? What's my original number? 20. Okay. Cross multiply. So I have 6,000 divided by 20. Can cross it, yeah? 2 times 3. Then I just bring both of those zeros up. Now somebody was like, well, how can you have a 300% change? All right, well, think about it. I know it just depends how much y'all go grocery shopping with the adults that y'all are with. But like eggs, the cost of eggs has gone up a ridiculous amount. Ridiculous. So I could probably say the cost of eggs have gone up by 300%. Easy. I mean, what, a dozen eggs used to be like $1.78, and now they're like $5 and something for a dozen eggs. Yeah, it's ridiculous. So that would be an example of how something could go up by 300%. It tripled in price. Okay? Yeah. Okay, and then an 82% change was like, well, it went up 82 cents if it was $1. Went it up to 182. All right, but this is definitely